happy to participate in yet another great NetEvents. So real quickly, I'll run through the participants who are on the panel today. They're shown on this slide, though their videos might be in a different order, so you'll have to sort that out. So we have Ron Nevo, who's CTO of cPacket Networks. And then we have Peter Phaal, he's president of InMon. And then Greg Mayo, chief architect in the CTO office of NetScout. David Iles, head of Ethernet switch technology with NVIDIA. That's good. He's waves. Good job, David. And Umesh Mahajan, who's senior VP and GM of VMware. Happy to have you all, and I hope to make this a very interactive and frank discussion. And as Mark said, we're going to be taking questions from the media at the end. So we're going to run this session for about 55 or 50 minutes, and then we'll start to take questions. So make sure you add your questions on the Q&A panel on the bottom when you have them. I'm going to give a brief presentation just to kind of set the context for the discussion, but I don't want to take all the time because I want the smarter people in the room to tell us what's going on. So let's move on, shall we? And let's talk about advancing network automation through AI and ML. I'm going to give you a few slides and context from Futuriom's research. And for those of you who don't know Futuriom and myself, I'm the principal analyst and founder of Futuriom. We've been around for about 3 years, and we focus on end user research and trends in the cloud technology and infrastructure markets. So I spend I try to keep 60% of my time dedicated to talking to end users, collecting data, and interviewing end users about cloud and communications infrastructure and what the new technologies are that are going to push it forward. So we'll move on to the next slide, and we'll talk a little bit about today's topic, how AI and ML are going to drive network automation. Futuriom did a report on this topic in August, and I'll present some data on that, some survey data. But first, some context on AI and ML. This is probably two of the most frequently used buzzwords in the technology markets. Sometimes abused, but ML is a subset of AI. So AI is, of course, the general term artificial intelligence, but ML is a specific technique. And I'll use Tom Mitchell's definition down here. Machine learning is the study of computer algorithms that allow computer programs to automatically improve through experience. So the important aspect of ML is that it can be trained, and the algorithms can be trained, and the algorithms can learn. And on the left side is kind of a general idea of what's happening in networks, where you're monitoring and you're collecting data, and they're using this data to train whatever ML algorithms you have to learn the patterns, and then they can automatically protect and respond to network events and correct themselves without human intervention. So that's, in general terms, what we're talking about today, just to set the table. And I'll move on to the next slide and provide some further context of why do we care about AI and ML specifically in networks. Well, there's actually many different applications, as I showed in the prior slide. AI and ML can be used to support closed loop automation. That's in a network where it's gathering telemetry and monitoring situations. It can be programmed to automatically respond to certain events, such as outages. It is used in these kind of networks to provide robust amounts of data to whatever algorithms are being used through monitoring, telemetry, and then generally fed into some sort of predictive analytics machine that can detect anomalies and faults. And the applications are diverse. It could be fault monitoring, but it could also be cybersecurity, detecting specific anomalies on the network to say, hey, that's a bad guy, let's shut that down. And then another application is just root causes and fault recovery failure. And then over time, again, because it's AI and ML, it can be trained to learn. The network can learn more about specific patterns or faults that might occur, and then make automated decisions about that. And another area that you hear about is intent-based networking. That's where we're programming the network to have an intent-based response, such as, this is a video application. The video application must always have a certain amount of latency so that we can see each other well. So there's many different applications of AI and ML in networking. And so that's an overview. So let's move on to the next slide. I've kind of broken this up into two areas. What's interesting to me is that we have some folks that are focused on telco networks. We have folks that are focused on cloud networking or data center networking, and then we have both. And I view, if you look at these three buckets, enterprise data center, public cloud, telco cloud, telco networks, they're kind of becoming more intertwined these days. They're becoming integrated and merged. In fact, I think you've seen some announcements where some big players such as VMware, such as Microsoft, are running cloud platforms for telcos that can run anywhere. They can run in a private cloud, they can run in a public cloud. So, but first let's talk about, if we're talking about public cloud or even private cloud automation challenges, many of the same challenges in all these areas, but the budgets are finite, the deployments are ramping fast, the bandwidth is surging, and the main problem is that many of the services are dynamic. And people are going to a website, they're clicking a button, they're turning a service on, and the networks have to be provisioned. So we need a certain amount of automated response, provisioning, life cycle management that has to be set up, that's not human driven, to respond to these dynamic services. And it's going to get even crazier as we add 5G. Millions of devices are going to be connected, phones, cameras, edge compute nodes, all sorts of things. So the only way to handle 5G, as I'll show you from some of our survey data, is to automate it. And then, as I said, the cloud services require fast activation and lifecycle management. So let's move on to the next slide. We did a survey in August about this, and we surveyed both cloud and telecom network operators, and we asked them, about 12 questions. So I'm going to show some of the results. And one of the questions was, do you think network automation will be crucial to supporting multi-cloud and hybrid cloud operations? And you can see overwhelming response, 93%. The end users really don't believe they're going to be able to roll out these services unless they have automation. They can't possibly manually configure all these services. Next slide. So let's talk about telecoms too. We talk about the cloud players, but there's also the telecoms players, which are building their own clouds, and they have similar challenges and probably even more pressing needs because of 5G. So all the research we've done this year shows that the demands of 5G are quite extreme. Millions of nodes, not just the cell towers and the compute nodes in the cell towers, but all the devices. And then we're talking about things like private wireless, where you're adding new compute nodes in industrial sites or oil rigs, or and then we have all, of course, the connected vehicles. So millions of nodes that need to be processed and connected and secured. And so this is going to have to be done largely through automation. The operational costs have to be kept down. Capital budgets are limited. We're spending a lot of money just on the equipment. So once it's operated, folks want it operated more automatically. And then of course we have the cybersecurity risks, which have to be automated as well. I showed how AI and ML are being increasingly used in cybersecurity operations to detect anomalies, provide services such as identity-based security. So that's going to be even more important, you know, in the 5G world. And the analogy as I use is you want a self-driving network just like you want a self-driving car. This person is reading a book. Now, maybe the network engineers aren't reading a book, but their resources can be used for better things, you know, long-term planning, you know, strategic efforts that don't require them scrolling through hundreds of alerts and just clicking buttons, which the computer can be trained to do. So let's move on, shall we? And here we have another slide from our survey, top goal of automation. I did mention costs, but actually in all the survey work we've done, the operational costs actually are a lower level concern. Now, of course, everybody likes to save money, right? But the larger concern is, you know, just smoother and quicker operations, you know, whether that's increased revenue service velocity, you know, being able to launch a service really fast. You think about all these, you know, VOD, the online video on demand services, how fast the services ramp, but you also need to automate that so you can turn the service on very quickly. Life cycle management, when you spin up these new services, how do you manage them? How do you manage the life cycle? And then, as we talked about, security needs to be automated. So move on to the next slide. And then, you know, this is what I've been talking about, 5G, when we asked that if automation is crucial to successfully launching 5G, overwhelming 95.6% say yes. They can't possibly connect all these things and manage them and secure them without the aid of some sort of automation. So let's move on, and I'll start the topic of discussion. So we have a great panel here. Like I said, many of the people on the panel are involved in both the cloud and the telco side, and then of course the edge where it all meets, right? So I'd love to bring the edge into the discussion a little bit, but let's talk about, you know, this public cloud, multi-cloud hybrid thing, which I talked about. The blurring of the lines and the connectivity between all these resources. Like, how and why is the increased use of public cloud, multi-cloud, hybrid cloud going to drive more demand for automation? And I'm gonna actually start on this one with David, you know, who gets to see a lot of this stuff, you know, on the edge, you know, from the compute perspective. So David, I know you had some thoughts on this.
Oh, thanks, Scott. Yeah, so I think the easy answer is, you know, people want automation because it drives down their OpEx and their costs go down. And, you know, anything worth doing more than once, you know, is worth automating. And it's the only way that some of these large, you know, data center operators can scale, is they can keep up with the demand. But I actually think there's something more subtle that goes on. There's a shift in private cloud and the skill set. There's kind of a cultural shift in the kind of people that are getting hired. It used to be that your IT staff for networking, the number one thing was you had to be certified in a particular network vendor's CLI, and that was the most important thing. Nowadays, it's the skill set has shifted where people want VMware certification, they want AWS certification, and so the people that are now deploying and using the private clouds, they are people that want APIs instead of CLIs. And that's a subtle change, I think, in just the population and the skill set. And so you do see this expectation too that says, I use a click of the button, they get rolled out in public cloud. that same expectation is now for private cloud. And there's a need to be able to shift resources from public to private and back and forth in an automated fashion. So maybe a slightly long answer, but I think it is a subtle change. It's not just dollars and cents.
Yeah, that's right. And like I said, it's all starting to blur together, and we hear about repatriation and some of the public cloud stuff coming back to the private cloud, but actually everybody wants to operate it, wherever they need the resource, right? So Ron, I know you had some thoughts on this. Do you want to weigh in on the how and why we're going to get automation in multi-cloud, hybrid cloud?
Sure. So there are a few things to think about. One is if we think about, well, first of all, I want to mention that automation should be thought about as two things. One is when you deploy the service. The other one is how you operate the service. And the automation, when you operate the service, is really the response to an incident or something that goes not as expected. And there, I think the machine learning and AI in general, machine learning specifically, plays a much more important role, because you really want your your automation framework, or AI ops platform, as some people call it, identify that something went wrong, root cause it, and then apply an automated action, which is a lot more complex than the deployment. The deployment themselves, or the deployment automation itself, is also a pretty complex and interesting environment where if before a lot of our customers were working inside a single data center, develop their own, now that they move to the cloud, they want to take advantages of native cloud services, whether it's S3 or Synapse or whatnot, to make their applications better and better scalable. And now you need to automate not only the things that you developed internally or your vendors bought, but also multi-services from other third parties that all have to be orchestrated together. So the scale, the variety of the environments makes the challenges of automation, just the deployment, a lot more complex than it used to be before.
That's interesting. So what you're saying is there's many different kind of groups of these tools, whether it's orchestration and configuration, operational, security. It's different buckets.
Right. Yeah, I think the good news is that the challenges are more complex, but there are a lot more tools out there and a lot more methods, and a lot of things that were developed into the cloud because of the scale will always had automation associated with them. So there are a lot more variety of solutions and tools, which is the good news in this environment.
Yes. Excellent. Great. Thank you. So Umesh, as we know, VMware is very active in many of these areas. So, and you probably have the most visibility into hybrid cloud scenarios. So tell us how you see, automation and then ML becoming more important in these areas.
So thank you, Scott. So yes, exactly. We are seeing the need for automation. It's not something just desirable. I think it's a must, because when you're in the clouds, whether private cloud or public cloud, the scale is high. You want to deliver your applications very quickly in an agile fashion, in a scale out fashion. So, and you don't have people in the cloud running around touching box to box, switch to switch, router or firewall or load balancer. You need to build that infrastructure, first of all, in a software-defined form and facilitate intent-based policy, then use things like Terraform or vRealize automation on top to build a rich infrastructure with first you can automate properly. Because automation will only happen when the infrastructure supports it properly. It's simple, intuitive, you can understand it, and you can do the right things. Then it becomes the intent-based policy, and then a little bit you alluded to intent-based networking. And that is the area where once you've done the configuration, deployment, etc., how do you operate it? And how do you mine the data collected? And that's where it becomes very, very interesting, is with AI, ML. How do you train the models? Where instead of individuals or operators putting hundreds of rules and trying to change them all the time, you have the system learn and you verify it and you make it better and better, because security and automation are also tied. It's not just setting up the networks. The challenge is the security. And I believe that's where we believe within VMware that's where the AI ML really comes together to bring out security settings in a proper fashion.
Yep, that's a great point. And I mentioned security absolutely is part of the automation puzzle. Well, thank you all. That's a great preview to cloud, and I'm going to come back with some further questions on that. But I want to go flip to the telco side real quick, and we have another question. So the question is how does this happen on the telco side? You know, what's different about the automation in the telco world? And I'm going to start with Greg, since NetScout has a lot of clients in telco, and ask him how he thinks it's different.
Well, I mean,
it's different at all.
I think it's just, again, kind of added complexity, because what you have now going on with 5G is it's another kind of leg of the stool, right? So we have all the complexity of hybrid cloud with everything that it brings, and now throw onto that a complete new networking architecture. So 5G isn't like when people moved from 3G to 4G. It really is like a complete redesign. So now they not only have to have automation to handle the virtualized aspects of this, but 5G inherently also has closed loop automation built in. So they're really having to deal with both at once. And, you know, again, automation, people have wanted automation for decades, right? And various companies have had more mature forms of it. Without it now, to Umesh's point, it's no longer you can get by without it. If you don't have it, you're done. And especially in 5G, and especially as 5G goes to the edge and the MEC, right? That's where the real values are starting to come in, and that's where you see the folks of the AWS and the Azures making a huge play for on-prem cloud offerings like Outpost and Wavelength and things like that. So I think it accentuates the must-have aspects of it. Otherwise, they're not getting these networks off the ground at all.
Okay, that's a great point. Now, Peter, let me let you weigh in. InMon, of course, has a lot of monitoring tools and expertise and automation on both sides. But what do you see? How do you see telco being different from cloud, if at all?
I think the exciting trend in the telco space is the adoption of commodity networking and compute technology in order to transform their services. I think it really offers an opportunity to reduce costs and improve flexibility. I mean, the promise of cloud infrastructure is that you can flex capacity as demand changes in a very dynamic way. And that's really the value that automation gives you. But I think it's worth sharing InMon's experience in this space, because we've been doing this for a long time in the commodity networking space, and this is what's being adopted by telcos. So I think the lessons are sort of instructive. We were really trying to do performance optimization software, and we realized that we really couldn't achieve that goal by cobbling together ad hoc measurements that various vendors provided. So we decided to collaborate with merchant silicon vendors and equipment vendors to integrate instrumentation into the hardware. So it's an integral part of the product. It gives you visibility into the data plane, which is essential if you're going to do automation. And that collaboration resulted in the S-Flow Industry Consortium and the S-Flow measurement standard. And that work continues. Most recently, we've been working with NVIDIA, and they contributed data plane telemetry to provide visibility into dropped packets. So now if a packet gets dropped by the silicon, you get to see where it was dropped, why it was dropped. And it really is going to be a transformational change in troubleshooting large-scale data center networks. The other really interesting change is the adoption of standard instrumentation in the Linux kernel now. So you can now use the same measurements from ASICs and from Linux servers, and that really helps when you're looking at service chaining and microservice architectures in POPs. So you want to be able to, for instance, monitor end-to-end packet loss, and it might occur on servers running some kind of packet transformation or within the network, and having the same kind of telemetry from both servers and the network gives you this unified view of these integrated services. And so I think given that kind of real-time telemetry from all the devices within the infrastructure, it really sets the groundwork to do very exciting and interesting performance optimization and radically reduce the costs of operating networks and provide much better service to customers, because you can spin up and spin down services on demand automatically based on the measurements.
That's great. Now, a number of you have mentioned the edge, so I'll be clear to the audience that there's the edge of the definition of edge is a little fuzzy, but the way that I see things happening is, what's interesting now is you have Peter mentioned POPs. Even the definition of a POP is becoming more fuzzy, but you have a lot of different players kind of going for this real estate grab at the edge. Now, the edge could be a central office near an enterprise. It could be inside of a Costco, some sort of edge device that provides 5G services and compute and AI. It could be at a POP like Equinox, like a co-location facility. But I guess my question to this panel is this is changing the dynamics in the industry. Is that going to facilitate AI, and does it matter where the AI is running or who's running it? I mean, where does it come from? Does it come from the POP or the edge or the public cloud? Or, I mean, help me. I'm just I confess, I'm just a French major. I didn't study this stuff. So,
Hey Scott, let me take
I have something to say.
I have to say, edge is the most overloaded term in the industry since software-defined networking and cloud. Right? Everybody has their own definition of edge, but we do see, it's no surprise, at NVIDIA, like, we have a point of view around AI, and we do see it everywhere. We see machine learning everywhere. It's from robotics and facial recognition. There's a lot of edge inference plays where not so much the training side of things, right? So if you understand machine learning, there's the training side and there's the inference side. We see that's where you can react to things very quickly. Edge, there's a lot of retail that are looking at AI to reduce, shrinkage in their facilities, and so there's their own area where they need that network to provide those AI services. But I think it's inevitable that the network automation itself starts adopting these AI principles.
Okay, that's great. That's great background. Let's have everybody weigh in on the edge.
I think
Umesh,
obviously the edge, to your point, is over talked about a lot, and really what it's bringing is new business models a lot of times for the carriers, right? Because in the end, it's still a network. It's still going to be, provided, in the case of the edge, it's often tied to the enterprise, right? And IoT kinds of use cases, but they're still providing a network, right? So the end user theoretically doesn't have to know, but what they're going to get is guaranteed service levels, right? For latency, throughput, depending on the use case. And, what I've found, we're doing a lot of talk about, kind of AI and ML, at least in our experience at NetScout, is we found that we try to apply, a tool bag, because there's no one just use AI or ML. We find different algorithms and different use cases might have, this is a good use case for unsupervised learning. This is a good use case for supervised learning. This is a good use case for a deep layer. This is a use case for a rule-based approach. And so we try to kind of use AI as a tool, because in the end, it's the automation. How you do it is, in the end, somewhat irrelevant to the customer. Certainly, we'd like to talk about the buzzwords, but you have to have it done. And we try to use a bunch of different techniques depending on the case. And the edge brings a few possibilities for that.
That's great. Anybody else?
Yes, this is Umesh. At VMware, our edge is from a SD-WAN portfolio, the branch edge. So two things are happening in the branch, right? One is the branch is going towards the high-end home, right? Executives or doctors, they're driving quite a lot of traffic, or Wall Street, brokers. So they almost have a branch edge box at the home, because they have more than one network, and they're trying to make sure that They have premium service all the time, right? So that's driving some edge into the home, and that needs to be monitored, because when people are working from home, they don't want anything to do with touching the boxes, managing them, anything at all. Plug it in, and I don't want to hear anything after that, because that's not my forte, etc. So that has to be centrally managed, and we have to make sure from the cloud, and make sure that time series thing, if anything weird is going on that device, we proactively inform the customer, etc. So there's that element coming in. Now we talked about like a Costco or retail. Their edges are becoming quite big, and they will have multiple 5G devices ultimately within the store, etc. Right? And these devices are not like the old IoT devices which used to send little or no traffic. With 5G, I think IoT will become reality because the bandwidth is much higher. Now the bandwidth is much higher, so you have to do network slicing across your WAN network over there when it comes back into the POP. There also, what do you slice? Who do you give more QoS, etc. That will become more important, and some analysis will have to be run backend in the cloud to decide what is important, what is high priority, how much bandwidth is this one taking. This one picks up in the morning, give it more bandwidth. This one picks up late night, they're doing some inventory or something, so change it around, and that happens. And finally, as this edge stuff is happening in a big fashion, there's this whole notion of SASE in the POP, right? In the branch and the POP. And that's where the security, working from home, or clients, users coming into the network, how do you make sure that all that is secure no matter where you're working from? And when you come to SASE, then this whole area of not only just automation, AI, ML to make that better.
That's great. Oh no, you had to bring up SASE, didn't you, Umesh? The
Yeah.
latest buzzword of the put it in your buzzword bucket. Ron, what do you think about this these new edge applications, and what is cPacket seeing?
Yeah, so I think that the edge, so when you think about automation in the context of telecoms or enterprises, you really have to think about end to end. And the edge moved the end to a different place maybe and added more capabilities there. But the reality is that the service that the user experience actually spreads the whole, whatever, some of the things are going to be in the edge, some of things are going to be in the data center, some of things are going to be in the cloud. And if a user complains about latency, it can be something that is happening in the edge, or it can be the communication to the authentication service that is running in the cloud or in the data center. So as you think about automation and visibility that allows you to resolve issues, you cannot just say, separate your organization, say, okay, just solve the edge problem without understanding how the service chain spreads across all of your network, all of your systems. And you really have to be able to collect the data from all the places, whether it's the branch or office or home, your data center, if you have to keep things there, and or the cloud, and be able to take run your algorithms over all these information to make a decision. You cannot really slice it in vertical ways because the service chain actually spreads end to end in your network.
Yeah, that's a great point. And my experience researching this market over the years is that's actually the most challenging point. I mean, Umesh was talking about the enterprise branch, right? And David and Greg were talking about, there are other branches too, private wireless branches, but there's also things like connected vehicles, industrial automation, oil rigs, which aren't exactly those industries aren't really savvy to the same cloud technologies. They've been using things like PLCs for decades, and they're not savvy to some of these cloud native technologies. They're obviously trying to move into that, but I guess Peter's a good person to answer this question. There's a different set of technologies in some of these vertical industries, and can the networking industry, which is traditionally catered to enterprise and cloud, can it transition to some of these new verticals and develop these kind of cloud native AI solutions? Big question, but I guess it comes down to the telemetry, right, Peter? Are the standards the same? How do we build the same standards?
Yeah, I mean, that's the thing is everybody's using the same ASICs from the same vendors in their switches, whether they're, no matter what the vertical is, it's likely it's going to be a Broadcom, a Mellanox, or a Marvell ASIC in there, and they all have the same measurement systems built into them. So, building on a secure measurement platform allows you to build stable control systems and stable automation, because you have a common, clean, well understood signal that lets you build controllers that can span these different areas. I mean, the problem's the same. It's Ethernet packets going over Ethernet switches. The applications above there, are infinite, but the core technology is well understood and well instrumented, and allows you to build automation effectively. I think AI and ML are kind of overused buzzwords, though. I think if you have good measurements, a lot of problems get solved by very simple controllers because you have good data. A lot of times ML is kind of misused to try and spackle over very poor data. And I think it's better to focus on having a clean signal and then building simple controls and focus the ML on the things that are really hard, like trying to understand human behavior and adapt your network services as people change their behavior. And that's a good use case for ML is profiling the users. But I think in terms of automating the behavior of the machinery, machines are well understood and behave predictably and don't need a lot of ML.
That's right. That's right.
A very important premise here, which is to really have good automation, you need observability. Especially, obviously, automation has the configuration day 0, day 1 aspects, but once you're in a continuous loop, you have to have observability, and not just observability to Peter's point, but the data has to be such that it's good data, right? Because you can take and run AI against not good data and you're not going to end up with good results. So it's really important to have a good observability model and very important to have a strong metadata model that has been gone through, because what we notice a lot in these spaces is there's some of the AI aspects is that domain knowledge that people have in the space about how to look at a certain type of data and know where the noise is versus the signal, and teaching the computer that is I think important.
Yeah, I think to add to that, I think the good thing about all the environments today is that they communicate over IP, UDP, TCP. So if in general, the amount of data, so I agree with everything that the guy said, it's really about the quality of the data. And the data can be divided roughly into 3 things, which is packet data, flows, and then events and server KPIs or server metrics. And just from the interoperability and the old, or what you call the legacy applications, at the end of the day, they all communicate with IP. So as long as you're able to analyze the packets at real time, at high speed, and extract the relevant information from them, you have what is the fundamental requirements for the AI machine learning. I think, some of the customers we've seen, maybe as they move to the cloud, what with the experience we've seen is they said, oh yeah, the network is a commodity, right? So it's all going to be services and applications, and we don't care about the network. And in reality, what we're seeing is that all of a sudden, one of the services moved to a different data center, added 20 milliseconds of latency, and all of a sudden they started getting phone calls because whenever they logged into their portal, people didn't get the expected response. So I think the important thing to do as you move to the cloud is to think through the data quality, and make sure that you don't lose the visibility into packets and the information that network data can give you, and not count only on the server or service or application information, because they might not give you the interdependency and the complexity between the services. And again, they may run in the edge, or they run in your data center or in the cloud. They still communicate, and having visibility in every single step of the place to see that. So I think what you started the circle with a monitor is critical and very high quality. I don't know that it's obvious that it's high quality, but you certainly have to have high quality information or data in order to run your machine learning algorithms.
Yes, that's garbage in, garbage out. That's the old saying, right?
Right.
So that's great. So I brought up this slide that I had earlier. I think you guys are all talking about this process of, like, we were on the monitoring side, gathering the data and then feeding it into whatever your machine learning algorithm or your intent-based system or your predictive analytics. And then, as we said, you got to have the data, right? And it's got to be clean. But what are the other dependencies here, as people like I know we got a bunch of nerds here, so nerds get annoyed sometimes by things. So when people are throwing around AI and ML in this networking context, like, what are the most annoying things? What are the most misleading things, or what are the crucial things, do you think, in this operating model?
I mean, for me personally, I think that some people focus on the fact that it's AI or ML versus what they're trying to accomplish, and which is automation. And, again, sometimes I'll have, either colleagues or friends, and I'll use the Turing test on them. It's like, if you can't tell the difference, then as you sit and ask the computer a question, then you're obfuscated to whether it's a person or a computer. And in the end, what are we trying to do? We are trying to automate. And that's where I get back. I think you all realize that AI and ML, I think, has been taken on such a buzzword kind of context that people throw it around in so many things. That's what frustrates me, is that we're talking about AI and ML. I want to talk about automation. I might not use AI. There's things to do in automation where you need to use AI. There's things where you don't. And I really like to focus on the results of automation and use AI as a tool. And that's when I get frustrated, when people want to just talk about it for the sake of talking about it.
Oh, okay. Am I doing that too much? So we talk more about it. Well, I think the diagram on the left here is, maybe we haven't labeled it right. That's supposed to be automation, right? We're trying to automate this environment, but the point being is there's a lot of different pieces to it. So who else wants to weigh in on that question?
Yeah, I think the
Raise your
AI.
hand. Peter, why don't we have Peter go next, and then Ron.
Go ahead, Peter.
Sorry. Yeah, I think one thing to think about when you look at that diagram, and this is something that I think most people overlook, is what's really important is how fast you can traverse all of those steps. That a good feedback system is fast. And if you think about how fast you can spin up a container on a server, or how fast you can reroute a traffic using dynamic traffic engineering, or how quickly a DDoS attack emerges, you need to be able to close this loop within seconds, not minutes or hours that it takes to sort of run through a lot of these, sort of like big data and machine learning pipelines. You have to have pre-programmed responses that can execute in real time if you're really going to produce stable control systems that don't, in fact, drive the system into an even less desirable state.
That's a great point. It's something I always, as an analyst, you must know I get slammed with 20 pitches a day in marketing decks and blah blah blah. And the funny thing is, somebody's always like, "Is that company great, or is that technology great?" And you can't actually tell by the description on the piece of paper, right? You have to go into a lab or talk to a customer and say, does it work? Does it not break, right? So that's what you're talking about. It has to work very fast, and it has to not break, right? Otherwise, the Uber self-driving car crashes into the traffic light, So let's get. I know David and Umesh probably have opinions too. Let's go to David first. David, what do you think?
Yeah, I don't know. I think if you're looking at pet peeves, I think it is a little bit of the people want to like run before they walk. I think that automation comes in steps. You have to have cruise control. You have to, to go to the car analogy, right? You got to have lane keeping assistance before you way before you get to the true self-driving car. And you need good telemetry, right? You don't fly a plane without radar. You don't fly you don't have a submarine without sonar. And the network's no different. You've got to have good telemetry to drive it well, to operate it. And that goes way before you start automating. It's like you have to understand what things are there. That includes, the control plane stuff. It includes a lot of the data plane stuff. And it can't be done in a, one-off. Like, you can't have one company out there just doing their own thing. It needs to be done in a standardized way. That's what I like, some of the work that's been done recently around kind of the telemetry, where we're looking at data plane anomalies that are captured in very standard ways. I like the stuff that's going on with in-band network telemetry, where a lot is being put into the packets as they traverse through the network and collect data on that. I like a lot of the work where we've been doing with, say, with Alibaba, where the network can adapt to dynamic changes, and it has to be fast loop. Like, you can't go to some centralized controller and then they analyze it and send it back. You got to be able to respond quickly. And so being able to take that closed loop operation, kind of like you see here, and take those advances in, data plane anomalies and in-band telemetry, and allow the network to adapt to that dynamically, very quickly, very rapidly. And we're seeing it deployed in the real world, but I think that those are kind of, the pet peeves. And there was a question that came up on the chat line about, like, what are good examples of how people are using ML and AI in kind of automation? And I'll tell you that maybe the simplest example is around security. Everybody knows about DDoS attacks, or the latest, thing where there's a clear signature for that attack. Well, then a lot of the tools, well, okay, they're fine because they've been trained ahead of time in a way. They already got that. But for new attacks, day zero attacks that nobody's ever seen before, I think AI and machine learning are the perfect examples of something that can say, we can detect this right now. You don't have to wait and be programmed ahead of time. So thought I'd throw that out there.
Great, thanks. Umesh, you got some thoughts?
Yes, absolutely. So I think when it comes to these closed loop analytics platforms, I think people forget about scale. If you're going to look at every packet through IPFix, and people claim real time and so on and so forth, that platform becomes inundated with traffic. So what we've looked at carefully at VMware, because we have a software-defined networking platform, we kind of do data reduction at the point of collection. In our software switch, when we are collecting the IPFix headers, etc., there itself we do a data reduction. We only keep what is useful for the ultimate analysis in our analytics platform. We throw away the rest, and we kind of encode it tightly. And then some actions we can take right away. Why go up there, do some analysis, come down? So whatever we've downloaded, pre-downloaded at the switch layer, we can take actions right away. But then the amount of data we are sending up to our analytics engine in real time is much, much less. It can analyze it in real time. Once we've analyzed it, we can take corrective actions, and we also stream that data out. No more polling of NSX. I run the NSX platform. No more polling, etc. We stream that data out to third-party partners, etc., so they can consume it and do more additional intelligence thing. So when you build these platforms, many people claim, like, they do a few insights, I'm doing AI, ML. No, you're not. You're just correlating the events, right? To do real AI analytics, you need real data, and you need a lot of data, but that lot shouldn't be that great that you can't even consume it. So how do you keep it in that bound? How do you design the platform? We've designed a platform that we use Kubernetes containers for the analytics engines, and as the load increases, we can spin up and use Kubernetes to scale out our platform all in software. Because I think that is essential. Then only you reduce the data, have a scalable platform, and then you will get the real answers over there in real time. Otherwise, after a little while, push in a little bit more data, and the platform can keel over.
Okay, that's a great point. So we're getting the questions rolling in. So I'm going to move to questions in just a moment. And again, we're taking media questions. So anybody from the media that has a question, put it in the Q&A queue, and we'll try to get to it. But let's move to a real quick wrap or a roundup. We heard, we heard a lot of different things. We heard that there's maybe too much emphasis on the buzzwords and less on the efficacy of getting to the automation. But so let me ask, like, where are we in network automation, and where do you expect us to be in 3 or 4 years? Kind of like we've used the self-driving car analogy. When do our networks become self-driving? I'll start with Peter and work our way across here.
I think that's happening pretty quickly now, as people are settling on a common set of building blocks. That dramatically accelerates progress because you don't have to try and solve a problem n different times with n different sets of blocks. Everybody's got x86 CPUs, they've got commodity ASIC-based switching and a common set of measurements. And so now with that common toolbox, I think we'll start to see a rapidly emerging ecosystem of very effective solutions because they don't have to cope with the complexity of a very diverse set of components.
Excellent. Great news. Ron, what do you think? How are we there yet? We're going to be there in the next few years?
I think we will be there. I think what the points that people were making before about closing the loop is the critical thing. I think that people invested in controllers, invested in data path, and invested in monitoring separately. I think they will have to connect the two. I think what we're seeing today is that the monitoring solutions are scaling and actually using AI machine learning to at least tell the user what happened, where it happened, why it happened, and when it happened, which is the 4 Ws that they need today. And the next step is connect them through APIs to the control system to go back and automate the response. And I just want to have one comment. I do see that I think the scaling comment is not that accurate. I mean, we are running today in data center at 100 gigabits per second, analyzing every single packet, and are able to give insights. So I think that the assertion that it has to be software is incorrect. And we're certainly seeing a combination of hardware, software solutions that are able to analyze every single packet, tell you about latency and the insights. I think the challenge for the next 3 years is going to be really connecting from the companies that have expertise in analyzing and understanding what's happening to the controllers that can actually react. I think that's what's going to happen over the next 3 years.
Excellent. Thank you. Greg?
Yeah, I mean, I think we're, back to your question, 5G is certainly accelerating it in the telco space because all the tenets of 5G could have been applied to 4G. But as they're building out the 5G networks, they're building in automation and AI like from the get-go. So I think as you're seeing the 5G networks come out worldwide, they are realizing it. Now that is taking time, right? So it's not like 5G is pervasive everywhere today, but I do see that it is because it's built in from the ground up, that it's kind of part of the ecosystem that they're building versus 4G, which is kind of
great point. And to that previous survey slide, 96% of people say they won't be able to do 5G without automation. David, what do you think? Where are we?
Yeah, so to take it back to your question of like kind of where are we on network automation, I take it back to the self-driving car analogy. I think we're in the level 1, where they got like 5 tiers, where it's driver assistance. So we have great tools out there for automation that are mostly, the really big scale stuff that we see out there come out of the server automation world. Salt Stack, which, the VMware guys are looking at acquiring, the Ansible. We see that as kind of this level 1. And level 2 comes as we start standardizing and getting better visibility to enable that closed loop operation. And I'll just, take a slight tangent because Ron touched on this idea that not everything is hindered by software. And I guess the point that I would make is that software runs on something. And so the hardware that it runs on can make a big difference. And, again, at NVIDIA, we have a pretty strong point of view that when it comes to any kind of an AI workload, it's going to just work better on, a GPU versus a CPU. And so you will find that even things that are software defined, things that run in a virtual environment, they run on, virtual GPUs. There's vGPUs, and that does, make a big difference when it comes to this highly parallelized model for AI. So hardware does matter, even in a software world.
Yeah. It's surprising that one of the largest chip vendors would think we need more hardware, but yeah, of course,
Yeah.
of course we need chips. Umesh, what do you think?
So I think this journey is definitely on, and it's net ops, security ops, AI ops. They're getting a little bit intertwined and overlapping. And I think that makes it very interesting because in infrastructure, you need all of the above, right, for the applications to run properly. And I think as we go down this journey rapidly, these areas are coming closer together, and there's a huge opportunity to monetize these properly, right? So I think all the vendors are driving hard to provide the best of breed, options over here. This is stuff which is evolving and it's on a very fast pace.
Excellent. All right. Well, thanks everybody. This was a really good panel and a really good discussion and very good questions. And I hope you can, I've done 3 of these now. We're doing them, I think Mark will correct me, I think we're doing them about once a month. So very interesting.